Welcome back to the channel. So from the last video you watched where you built your game where you had the computer or the player chose a number, and I think you modified that where you said the JavaScript chooses a random number and then it sets it as player 1, then player 2, your job is to guess it. So if you built that, great. Why don't we continue on? Let's look at some slides about logical operators and the rules of how logic works. So let's talk about logical operators. And the first is that logical operators allow you to compare the results of more than one comparison. And I think we talked about that before. So here's an example. And let's look at those two slashes in the middle. Those denote the word or, and or is a logical rule. And we're going to go over that later. But take a look at how it's compared, right? 3 equal to 2 and is 2 greater than 1. What you should understand is that each of these are wrapped in parentheses as a grouping symbol, but all of this is wrapped in one giant grouping symbol. So we logically express things, and when we evaluate them from left to right. If the first condition can provide enough information to get the answer, then there's no need to evaluate the second condition. So if we think about it, what we're saying is we're going to compare to see if all of these things are true. If the statements are true, based on a logical rule, then we're going to run the syntax. We're going to run the code inside. All right. So why don't we take a look at logical AND? So AND with the two ampersand symbols, and on your keyboard that's above the number 7. And so we're going to test more than one condition. If both or all of these statements evaluated true, then the expression returns true. But if one of these are false, then the expression is false. So for example, true and true equals true, true and false equals false, and of course false and false equal false. So AND is an important one to understand because it says you're checking all the conditions. So in code we could say, like, let's check their name and their grade, and if they're the right name and the right grade, then you can continue to class. For example, let's look at this. So cam and cam and stem. Is cam equal to cam on the left? Well, no, because one's lowercase and one's uppercase. And because that first set is false, it doesn't matter what the second set is, that entire statement is false. So let's talk about logical OR. So we test more than one condition. And if any of these return as true, then the entire expression is true. True or true. By the way, these two slashes are above, if you're on a Windows keyboard, they're above your enter key and under the backspace. It's just a straight up and down line. So a true or true is true. True or false is also true. And false or false is still false. So all we need is one thing to be true for the entire statement to be true. Now let's take a look at this again. Cam equals cam or stem equals stem. Well, we know the first part is false, but the second part is true. So false or true is still true, right? Because at least one condition must be true. And let's take a look at logical NOT. That's just an exclamation point. So all we do is take the single value and we invert it. So if it's true, then it's going to be false. If it's false, it's just going to be true. Really easy. It's not that hard. So let's take a look at this. Is this true or false? Well, if you said false, this is correct because one's a string and one's an integer. How about this? The answer is still false because even though it's an OR statement, both are still false because one's a string and one's an integer. Now let's take a look at this. So let's look at the first set. 10 equal to 10. Well, that's false, but if you notice, there's a not symbol in front of it. So not false is true. So the first part is true. Let's look at the second part. One's an integer, one's a string, but it's not false, so it's true. So you should end up with true and true. So this entire statement is true. Why don't you do this one and figure it out? Now remember, we evaluate left to right, okay? So if you have the answer, you can, if you want to pause it and check it, great. If you want to unpause it, get the answer, that's fine too. How about this one? You can pause the video, check it, and then come back. Alright, So here's what we're going to do. We're going to modify the 2-player game we built before. All right. And we're going to say 1. So if you want to pause the video right now to write this down or take a picture of it, that's fine. So we're going to tell the players they can only enter numbers between 1 and 5. If they enter anything else that is not 1 through 5, we tell them that they cannot follow directions. If the players enter a number between 1 through 5, tell player 2 if they won or lost, and output all the values to the window alert. So this is just the same thing you built the last time, except number 2, right? We're going to basically force them to enter a number between 1 and 5. If they haven't entered a number between 1 and 5, then we need to tell them you did not follow directions. So I'm not going to write the code for you, but if you've done this properly, then you use a evaluating condition to say, like, you want to check player 1 to say, like, if the number is greater than 5, or if the number is less than 1, then tell them that you're out of range, right? That those numbers don't exist. If you're in my class, though, I'm going to check that code. So this is the same way to say, like, when you enter a password into a field, right? Or you enter a username, it always checks. Or let's say password's a better example. It's to say, like, look, if you don't have a symbol, I'm going to scold you. If you don't have a number in your password, I'm going to scold you. And that's just what the code does, right? It error checks these things for you. And as a programmer, that's your job to make sure you have error checking. So, just build it out. So why don't we talk about loops in code? So loops in code is pretty fundamental, especially when you're running if-else statements. I think in the last slide that you watched, we need to decide if we have to loop again and again through a decision-making process. So in the loop, there's 2 key concepts. There's a break or a continue. If you want to pause the video and read that, go ahead. But break basically exits your loop, and then you just continue to keep running the loop. So there should be some performance issues that should know of, and I think this really applies for, like, older computers. When a browser comes across JavaScript, it stops doing everything else until it has processed a script. So if your loop contains a lot of stuff, you can make your web page really slow, or you can make your code really slow. And if the condition never returns false, then you're going to get an infinite loop. And so the computer is just going to keep running and running and running. And it's going to break your computer, and it's going to crash your browser because your loop is out of control and it doesn't know when to end. Right? It's like you being told keep running, and then when you ask when you have to stop, no one tells you. You just run till you pass out. So there are 3 types of loops: the for loop, the while loop, and the do while loop. In this context of these lessons, I'm going to cover the for loop and the while loop. The do while, we can look at resources later on that. All right. So if you want to pause the video, if you want to look and read what these things are, great. And when you're done, unpause it, and then we'll move on. So let's talk about the for loop. So in the for loop, there's 3 parts. We have initialization, we have a condition, and we update. So in initialization, we always set something to 0. And then the condition, or how long should I run? And then finally we update it, because every time the loop runs, we add 1 to the counter. And let's look at the syntax. So we have for and the condition, and then the code to execute. Okay? So why don't I run a sample for you now, and we'll discuss it together. So why don't we take a look at this code sample. So I'm going to say for, because I want to run something, and we say var I equals 0, because I is your counter, and we always start from 0. So I put a semicolon there. And how long do I run this for? I want to say as long as it's less than 5. Now this is important that you understand, because when we count in code, remember, we always count from 0. So as long as I is less than 5, we're going to run. So if you count with me and you hold up your fingers, ready? 0, 1, 2, 3, 4. If you've done that properly, you should have 5 fingers up. And as long as I is less than 5, it's going to run. And then we increment I++, okay? And then we have our mustache braces. So why do we make, this is going to be really annoying for 5 times, but that's okay. And why do we say window.alert hello? All right. So if I run this, it's going to say hello 5 times. It's going to make a pop-up 5 times. So hello 1, hello 2, hello 3, hello 4, hello 5. All right, so it starts from 0. It's going to check it to see is it less than 5? Well, yes. Then I'm going to add 1 to I, so I will now equal 1, and then I'll run this, and it's going to do this 5 times. So looking at these slides, for variable I equals 0, I is less than, in this example it's 10. If yes, add 1 to I now equals 1, and we run the code. Is it less than 10? If yes, then you do it again. So if you want, you can practice this, right? And you notice that I said window.alert and the I. It is to prove to you that the number is just going to go from 0 all the way to 9. So if you want to run this now, that's great. And then, just pause it, then unpause it, and come on back. So this is what you're going to do, right? You're going to build a pop-up window that displays numbers between 1 and 10. And that's just kind of what you did. So do this practice. Let's talk about the while loop. So a while loop runs until the condition is true. So if we look at this, it looks a little confusing, but it's okay. All we're going to do is just output this thing the 5 times table up to number 10. So all we're going to say is we're going to multiply this number by 5 and then until it stops. We're using something called DOM inner HTML. I'm going to teach you that later, but if you want to pause it and write this code out now, then you can do that. So that's kind of the basic examples of running for and while loops, and we'll practice more of that later. If you get a little confused, and for and while loops are really, kind of technical, jump online. I'm going to put some resources down in the comments below. If you're in my class, then we can practice these in class together. Other than that, I guess I'll see you guys later. Bye.